I'd like to look through a short example on how to use what's called the comparator interface and the comparable interface. So we can look at the difference between these two as we look at it. We are going to use a comparable interface in Module 6, I think it is, and we talk a little bit there about the comparator interface, and then in Module 8 we actually are going to look at the comparator interface. And so I'd like to do both so you can look at them. If you would like to go through and sort arrays, some people have found this really cool way to do things with arrays.sort. You can actually also use a collections.sort if you have a collection when you do that. And so let's say I had these strings here, names of strings, and I print them out, and then I found this great method called sort in the arrays class. Okay, and so I try arrays.sort, see what happens, and I try to print them out. And if I now take this guy and I run him, that's pretty cool. In one line of code, it's sorted for me. It'll also do a binary search for you, things of that sort as you go through. Kind of really neat thing to do, and you're thinking, wow, this is really exciting. Well, part of the problem is, there's always a problem, isn't there? That's wonderful, and Java knows how to sort strings, to actually sort out strings. But the question is, how do you sort other things when you do that? All right, I want to sort employees. I want to sort stock. I want to sort invoices. I want to sort a variety of things. How do I sort them? Well, Java has no way of sorting them, natural way. That's the same thing as I mentioned to you that every time we do a blueprint, we must write a toString method. The toString method indicates how it's going to come out looking on the console, because there is no standard way of writing out an employee. So we write a toString method to write out an employee. Okay, pretty simple to do that. Or to write out a stock, or to write out an invoice. So we always put a toString method in our class that will actually allow it to write it out to the console. All right, how do I sort things? Well, Java knows how to sort things. It knows how to, it has routines for sorting. That's not a problem at all. It just doesn't know what order you want them in. If I have employees, do I want to sort those employees by first name? Do I want to sort them by salary? Do I want to sort them by IQ? Do I want to sort them by last name plus first name? What do I want to do when I sort them? Because I can do the same thing, a very similar thing to this, arrays.sort, or I could do it in collections if I want to. Collections.sort if it's an array list, so it can be an array list, whatever it is. We talked in Mod 8 about all the different types of collections that Java has. But I need to have some way of actually sorting. Okay, so what does Java require? Well, for Java to sort for you, first thing is we must implement an interface called comparable. Comparable is a Java interface. A Java interface is like a class. There's the word type, T-Y-P-E, that are Java classes and interfaces. Java classes and interfaces both have fields and methods. Okay, the difference is that interfaces, all of the fields are final, they're constants, and all of the methods are abstract, and that means that they don't have a body to them. I think of an interface as a contract. It says, if you want to be one of me, you must do something. And what must you do? You must write certain methods. All right, if you want Java to sort for you, you must use the interface, and to use interface, you use implements, comparable. And notice I'm comparable of an employee because that's what I want to do, is compare two employees together. Now, interfaces are contracts. It says, if you want to be one of me, you must do something. For the comparable interface, you must write a method called compareTo. The compareTo method tells Java how to compare two employees. All right? And if you don't write a compareTo method, Java is going to force you to. There's going to be a compile time error that says you must implement comparable. So if we look down here, I have a compareTo method here. And if you notice, if I comment this out, I get a red X. And when I hover over it, Java says the type employee must implement the inherited abstract method comparable employee.compareTo. That says you must write the compareTo method in this employee class, okay? And so it's not going to let me get away with not writing it. How do I write a compareTo method? Well, I decide what I want to compare. I want to compare, notice I'm in the employee blueprint. Okay, and so what I want to do is I want to compare this instance, the one that I'm in, with the one I'm passing in. So first, notice in the compare to method, you pass in another object. So I want to compare these two objects. All right. Notice also, we're in an interface. When you implement an interface and you write the method, you must write the exact signature. It must have the exact signature. So it must return an int. Now you might say, why would compare to return an int? Well, what happens is that if it's a certain order, it returns a positive. If it's the other order, if it's in order, it's a positive. If it's out of order, it's a negative. If the two are equal, it's a 0. So there's really three choices. The two employees are actually the same object. Okay, one is greater than the other one compared by whatever you tell them to compare by, and the other one is less than. All right, now in our employee class, very simple. If you look at it, the name is just a single name, so it's like Joe, Sam, Mike, whatever it is when you actually do that. And so in the compare to method, notice what I did. If emp is the one I'm passing in, dot get name. That's kind of interesting. I'm using the compare to method inside the compare to. First look, it might be recursive, but it's not. This is actually using the compare to method that's in the string class that already exists. So I'm going to take the one that I'm passing in's name and compare it to the current object's name. Okay? Now, as I say, compare to returns an int. So if that is less than 0, return a 1. You could have returned 1,000. It's returning a positive number. That's what matters. Else, if it's the other way, if it's greater than 0, return a negative number. Pick your favorite one. Otherwise, return 0. Okay? And so what we're doing here is we're looking at how telling Java what order means in employees. So we decided to do it by name. So this will come out alphabetically. If I had changed this to, you know, get one of the other fields like salary, it would have sorted by salary when you do that. All right. Now that I've done that, okay, I can actually come out here, and I'll do a simple example for you so that I don't have to look at the other one. Then we'll look at the other one as we go through. Okay, if I actually come out here, well, maybe I won't, because then I have to create some employees when I do that. If I now use now that I use the compare to method, well, let's do that. Okay, so I'm going to sort emps. How's that? Okay, when I do that, public static void main, I can do that, finish. Because then I can show you some changes here. And then we'll look at the whole application. All right, I'm going to create an array list of employees. It's an employee. E equals new array list of employee. Okay, and again, it doesn't know array list. Hover over it, import, life's good. Now, my employee constructor is, what is it? It is name, age, and salary. I can do that. All right, so I'm going to do an e.add, name, Joe, age is 23, and his salary is $10,000. How's that? Poor guy didn't make a lot of money, huh? Why doesn't it like add? Well, I guess what we need to do is figure out what method we got. Oh, yeah. I can't just add those things. What I have to do, that's just silly, I have to add a new employee that has this field. That's called an anonymous object. He didn't really get a name. He's actually getting put on the 0th order of the array list, and that's okay. That's the way you can add information in. I'm going to add Adam in. Just happen to like Adam. I'm getting all this email coming through. Adam's 34, and he makes 20,000. Sad. Okay, when he does that. And then we're going to do an e.add. I got to make that new small up there. I'll do that in a minute. Employee, and we're going to add Sam. Okay, Sam is 21 years old, and he makes $5,000. Doesn't work real hard when he does that. Okay, poor guy when he does that. So that's all right. We can live with that. So if I take this guy, okay, and now I do a public print or public static void print. And I want to print an array list of employees. I'll call it EM, whatever that is. I can do a for int I equals 0. I is less than m dot size I plus plus. I don't even know if we have a toString, but let's hope so. System.out.println em dot get I dot toString. There we go. We got a toString method. That's cool. From the employee class. Cool. So if I now come in here and I do a print E, and I run this thing, look at those. Name is Joe, age is 23, salary is that. That's a really ugly toString method, notice, that I wrote in here. So that's okay. We can do that. Now, the cool part about that is I now can go and do a collections. We talk more about this in Mod 8, .sort E when I do that. And then I'm going to print E again. And so if I now run this again, it printed it once. Okay, I didn't put a space between and then print again, but notice I've got Adam, Joe, Sam. And so they are indeed by names when you actually do that. Okay, that's pretty cool. Now, if I really wanted to sort them by age, is all I would have to do is go out to employee, and I would have to just change this emp.getAge. Well, let's actually do that. The question is whether I'm screwing up my other application. I probably am. We'll look at that. But with age, you can't use the compare-to method. I think one of the biggest problems is people would write an emp.getAge compare-to. Just kind of copy this. Remember, an age is a primitive data type. They do not have, it's an int. They do not have methods. So instead of using compare-to, I just use the greater than sign and the less than sign. And I've got examples of that in our other applications, so I won't change it now, which will screw things up. All right, cool. So point being, if I want Java to sort something for me, I have to tell it how to sort. One of the ways to do it is to implement comparable. Notice, even if I put that compare-to method in here, and if I don't write this, okay, and then I go to sort employees, it comes back and says, bound mismatch. This is kind of hard to read all this. Is not applicable for the arguments that. It's a substitute. That one, boy, that error message just really is hard to read. It's essentially, I'll tell you what it says in English. It says, I can't sort them for you. And the reason I can't sort them for you is because you did not implement comparable. Okay? Now, it could still sort them if you go through and give it like a bubble sort, okay, or something of that sort, but it can't implement. But it can't sort it itself because you have not told it that it implements comparable. All right. Now, how does it actually do the sorting under the covers? I don't care. It's called encapsulation, information hiding. All right. It does it, and that's a good thing. What if I want to sort two ways? What if I would like to sort by name one time and by age again? In Mod 6, I'm making you do the second one by hand. Actually, I'm making you borrow code, so it's not a big deal. You should see the raw code for searching and sorting over, a couple times so you get used to that kind of thing. But is there another way Java will do it for me? And the answer is yes. Java will do it with another interface, okay, called Comparator. Comparator. Okay, now when you use the Comparator interface, you do it a little bit differently. What you do is you actually write another class. And this is where I can show you that age thing I was talking about. Okay, what you do is you write a class. Notice I didn't make it public because it's only going to be used for this application. That's fine. And I implement comparator of an employee. The question you need to ask yourself every time you implement an interface is, what methods do I need to write? I'm glad you asked. The answer is the comparator has a contract that says you must write a compare-to method and tell me what two things you're comparing. Now you might say, why two things? The other one only needed one. This is its own separate class. The other one was in the employee class, and that's why I already had one instance of the employee, the one that I was in the class, and so I only had to pass it one. Here I have to pass two. So notice what I did was on line 9 and 10, I went and got their ages. And then the same kind of concept, the compare method returns an int. And so if the if the emp1's age is greater than emp2 age, return 1. Notice how I used greater than. I cannot use the word compared to in here because there is no methods for primitive data types. The reason I could before is because there is a compare to method in the string class of Java. Else, else, else. So I've written a little class that says I want to be able to compare to I want to compare two employees and their ages, okay? Because I'm passing in comparable employee when I do that. All right, now I've got a larger example that will use this, and we'll look at that as we go. If I look at employee driver, okay, what I'd like to do with this is I loaded some fake data in here, okay, a bunch of employees. When I do that, I'm also showing you some other methods in here that are kind of neat to see. I add some methods to an array list. I also have an array of employees. I can do an arrays.sort. It'll sort just the emps, these guys down here. There's a cool little method we talk about in real detail in we'll do details of all these in chapter 8. I mean in mod 8. I can convert an array list, okay? I can convert an array, my emps array, into an array list, and then there's a cool method in array list that says add all. You take a collection emp, which is all these guys up here, and I can add all of these guys to it, and now I have an array list that has both, just to show you how that works. That's pretty cool. To sort names, I did it just like I did in my sort employees here, collections.sort. Here's the thing I want you to see. How do I use the other version of it? Well, it's an overloaded, remember overloaded, same method, same class, different parameter list. It's an overloaded method of sort where you pass it not only the list you want to sort, but how you want it to sort it. So I pass it a comparator. So by passing it this age comparator, it knows I want to sort by ages. Okay, when I do that. Now again, how does the sort method work? I don't know. You can look it up. It'll tell you which kind of sort it's using and how efficient it is and everything else. But that's the second way I can actually do the sort. And that's another way to do it when you do that. So if I actually take this employee driver and I run it as a Java application, again, kind of hard to see the output here. Boy, I could have made that a whole lot better output. And maybe I will work on doing that. But all this driver did was it loaded the data, it sorted the names, it printed the data, it sorted them by age, and then it printed the data. Okay, so it loaded the data, it sorted them, and before I give this to you, let me do this. Let me just do something here real quick. System.out.println, original data. Okay. And then I'm going to do, oops, I need a semicolon at the end there. That would be a good thing to have. A system.out.println. And notice I'll put a backslash here so that they get separated by a space. Sorted by name. And then I'll do a system.out.println. Sorted by age. So I've got them sorted both ways when you do that. Alright, so now if I run that again, it might make more sense. Again, ugly output. Oop, what happened to the other one? Oh, there we go. Sorted by name. There they are. Oh, I actually didn't print out the original data. There you go. Sorted by name. Notice the names are all sorted there. I'm slow here. They don't have to be unique. We'll talk in chapter 8 about how to make them so they aren't unique. And this one's sorted by age, it looks like, as you go through. All right. So what I will do with the original data, I'll just, so that when I give this to you, it'll make sense, is I'm going to stick that here. So we can see that actually worked. So that's how you do sorting. That's also how you do an interface. We'll talk a lot more about interfaces as we go. Thanks.